So it's a micro-trenching and mini-trenching trial. So an explanation of micro-trenching and mini-trenching. Micro-trenching is trenching that's around about 80 millimetres wide, and mini-trenching is trenching that's between over 100 mils wide to 300 mils wide, and around about 500 millimetres deep. But generally the rules are at least 600 millimetres deep in the road, possibly a metre. And therefore, for micro-trenching to perhaps go further, councils may have to look at their standards. What we're doing is we're laying the micro-tubing along the road and we're putting in 2 tubes to the boundaries, each second boundary, and those 2 tubes will peel off, 1 to each house. Now, as far as the MED trial goes, we are trialling to the boundary only. We as Chorus are putting in a cabinet, and that cabinet will actually have the big tubes that are going around, the 26-way tube. They can come up into that cabinet, and then the tubes will allow the fibres to come out and be jointed into the feeder fibres from the exchange. We will be using a truck that Gail will explain to us from Mario Lucas how it works. It's called a CleanFast truck. That'll be doing the micro-trenching, mini-trenching, 500 mils down.
That's the limitation of the machine. The limitation of the machine is 500 millimeters. Just to give you some background of MARACE, we start to develop the micro-trenching technologies. The initial idea at the beginning of this development is really what was why continue to open quite big trenches, usually 300, 400 millimeters wide, 6 to 1 meter deep, just to lay small cable like this one. So the idea was to minimize as much as possible the trenches, to lay the fiber optic cable, to minimize the disruption for the community, for the towns, to try to speed as much as possible the process and to minimize the cost. The first step of the process is, which is the most important one, is the location of all existing systems. Without this type of technologies, GPR technology, we won't be able to use such equipment. As we are doing, and you will see quite fast, when you discover something in the ground, it's too late. We operate the machines in quite narrow situations. So one of the beauty of the CleanFast machine, as you can see, is that we can make very, very tight curves. This is a common organization of the CleanFast job. We have the CleanFast machine opening the trenches, an equipment laying the cables or the pipes, and the final equipment which is pouring the mortar into the trench.
The cutting tool at the rear is remote control. There's a driver driving the truck at the front.
Yeah. The only role of the driver is to drive the truck as straight as possible or to follow the line. We are able to operate the cutting wheel in 2 ways. The first one is the cutting wheel is just following the movement of the truck. The operator can take full control of the equipment and can operate the equipment in 3 dimensions completely independently of the truck. So the truck could go straight and the operator could avoid the specific obstacle just with the remote control. The driver has 2 cameras, one at the back to follow the marks or the elements, and one at the rear of the truck to be able to see what happens at the back. Cutting equipment. The wheel is mounted with carbine flex teeth. When we want to change the width of the trench, we just need to adapt the teeth support. The operator has many systems to control the depth. In operation, as the wheel is all covered, there is no safety issues. It's a very, very safe machine. full, depends on the dimension of the trench. It's roughly between 50 to 100 meters. We have to stop and down the truck into a simple resting. So this is the backfilling operation. So we have, as I said, most of the studies were to define the good mix and the good characteristic of this product. So this product is simply poured into the trench with a small edge or hopper and attached